If you haven't printed out this worksheet for this lesson, I would pause the video and go ahead and do that. And make sure you have this. If you're referring to your ebook, the geometry lessons we're doing are in Chapter 8. Okay, so for this lesson, we're going to be finding some areas of figures and perimeters. So let's look at this one here. Now, this figure is not on here, but you'll notice that it's made up of two figures that we do have a formula for. We have our rectangle here, and so I'll just put area, and I'll put a little R there, and we'll write that formula down. And this one here is on our sheet, and that's our trapezoid because we have two parallel sides. And the formula is 1/2 times height. The height's always measured straight up and down. Let's pencil that in. And B1 and B2 are the two bases here. So for our rectangle, it's length times width. We should know that one. And the area for our trapezoid is 1/2 of the height times the sum of the two bases added together. Okay, so we have 1/2. If you want to change that to 0.5, that's fine. The height is 2. And this base right here is 8. So that would be 8, and that would be 4. So we'll add the two bases together. And using our order of operations, we'll do this first. So we have 1/2 times 2 times 12, and just multiply from left to right. Half of 2 is 1. 1 times 12 is 12. Now, we need to put some units here. That's going to be in meters squared because it's area. And then for our rectangle, that's an 8 by 4. That's 32 meters squared. And then what we'll do is we need to add those together, and our total area is 44 meters squared. Now for this one here, we have a restaurant owner wanting to buy carpet, and we have a main dining room and a hallway. Now be careful, our final answer is how many square yards, okay? Now what we can do is we could go ahead and change these to yards first, or we could go ahead and find the area and then change to yards, which would actually be a little bit quicker, because if I do it now, I have to change that one, that one, that one, that one, or if I just wait, I can change my final answer. So you need to find the area of this rectangle and this rectangle. Anytime you want to pause and try things yourself, do so. Okay, so my area for this rectangle is 42 by 48. And for the smaller one, the hallway, it's 16 by 9. And you might want to have a calculator handy. And so we have 42 times 48. And we need to remember that's in feet squared, so that's not going to be, that's got to be changed. And that's 144 feet squared. Let's get our total. 144 plus 2016. That's 2,160 feet squared, okay? Now we need some kind of conversion here. I know that in 1 yard there are 3 feet. In 1 square yard, that's still a 1 because 1 squared is 1. It's 9 square feet. So if you remember when we're converting, we want to change it to square yards. And I'll put that over the 9 feet squared. And that will cancel those units out, and we're going to divide that. And we get 240 for our answer. And we need to make sure we put labels because those are important. Okay, let's see on the third one here. This is also an area problem, okay? We got a couple of ways we can tackle this. We could cut it down right here. Or you could cut it here if you want to try something different and see if you get the same answer. Or you could even make a box here and find a large rectangle and subtract a small rectangle. I'm just going to do this right here. Okay, so we have a 6 by 7, that's 42 if you multiply. This is 4. Now, all the way across is 12. That's 6, so that would be 6 here. And so 4 by 6 is 24. And we'll add those two together to get the total, and that's 66 centimeters squared. Now, this next one, we're trying to find an unknown length. This is not an area problem, an unknown length in a right triangle. There is a formula for that, and it's only for a right triangle. On your formula sheet, that's the Pythagorean theorem, and that says that if we square this length and square that length and add them together, that is the length of this long side squared. This long side has a name. It's called the hypotenuse. I'll write that down. And A and B are the legs that make the right angle. So the two sides that make the right angle go on one side added together. The longer side is by itself. Okay, so the Pythagorean theorem, let's write it down. I like to write down formulas to become more familiar with them. That's 3 squared plus 4 squared is equal to that longer side squared. Order of operations, we do each power first. That's 25. Now this side is not 25 units long. That is how long, that is the value of it squared. To finish this up, C itself is, we're going to have to unsquare that, take the square root of 25, which is 5, and that is in kilometers because it is a length. It's not going to have a square on it. Okay, we have another missing side here, and this one looks a little bit different, but one thing we could do is you can flip your paper around and make it look like what we have on the formula sheet. There's our right angle there. Here's our right angle. This time we're given the hypotenuse here. So we know A, we know B, we don't know B, we know C. So when we put that in, copy my formula, A squared plus B squared equals C squared. That's 3 squared plus B squared equals to 11 squared. Let's simplify, that's 9 plus B squared. 11 squared is 121. So if I'm missing one of the legs of the right angle, what I'm going to have to do is subtract to get the problem finished. And so we have 121 minus 9. That's 112. Okay, and then we're going to take the square root, and we're going to need a calculator because that's not a perfect square. On this calculator, I just have my number in there, and I hit that. And B be the square root of 112, and that's approximately, I make a little wiggle sign when it's approximately, and we'll just round that to 3 decimal places. They'll give you rounded instructions in the homework, and that's in feet. I'll use my feet symbol there. Okay, this is a Pythagorean theorem problem because we have the right angle here. We are missing a leg. We're missing A. We have B, and we have C. And so we have A squared plus 15 squared is 28 squared. We'll simplify the exponents. 15 squared is 225. On this calculator, there's a shortcut button for squaring right here. And then 28 squared is 784. Remember, when we're missing a leg, we have to subtract. And so that side squared is the difference between the two, but remember, I want to know what the side is. So A itself, we have to unsquare. The opposite of squaring is a square root. This is not going to be a perfect square, so we'll round it. We are given instructions on this one, round to the nearest tenth. That's one decimal place. So your number's in there. You hit this button here, and that's about 23.6, and that's in feet. And we have another Pythagorean theorem problem here. You might want to pause it and try it now that we've done a few of them. We're missing one of the legs. Looks like the longer leg. So we're given A. We're given the hypotenuse C. We're missing B. So A squared plus B squared equals C squared. That's 6 squared plus B squared equals 22 squared. 6 squared is 36. 22 squared is 484. We need to subtract because we're trying to find that leg there. Got to get it by itself. 484 minus 36, 448. And on this one, on number 7, we are going to get a decimal answer. We're going to take the square root. It says round to the nearest tenth. I've already got the number in the calculator, so all I have to do is hit this button right here, and I get 21. That would round to 2, 21.2. Again, you want to use a little squiggle. And that's 21.2 feet. Okay, and then let's see here. Find the area of the figure. Let's go and look at our formula sheet. This is not a right triangle. But for any triangle, right triangle, any type of triangle, your area is half the base times the height. Your base and your height are always measured at a 90-degree angle to each other. So these will always be what we call perpendicular. So we're taking 1/2. The base is 6 3/4. The height is 5. I'm going to do a little work by hand. I'm going to change this to an improper fraction and try to do most of this without a calculator. 4 times 6 is 24 plus 3 is 27 over 4. And we have 5 over 1. To multiply, you just multiply straight across. 27 times 5 is going to be 135. 2 times 4 is 8. Let's see, let's change that to a mixed number since the problem was a fraction. Usually in a homework, if you're given a problem with a fraction, they want you to keep a fraction form answer. If it's a decimal, you give a decimal answer, so that's typical. So let's go back over how to change that to a mixed number. 8 goes into 135 one time. 8 into 13 once, minus 8. 8 goes into 55. Let's see, 8 times 6 is 48. Don't stress out there. That is just the emergency warning system. We're having bad weather today while I'm doing this. You subtract that, you get 7 over 8. Make that a little bit clearer there. I got my work squinched together. Okay, so the area is 16 7/8. What? 16 7/8 meters squared. Okay. Continuing on, we have another area problem. Again, that area formula goes for any rectangle. And if you want to work anything, pause the video and try it yourself. That's how you learn. They're letting us use decimals here, and so we'll give a decimal answer. So we'll just use the calculator. Let's change 1/2 to 0.5. And I need my base, my height. Well, I'm given three numbers here. Well, what do I use? Well, we're going to be using this for the base and this for the height because they are at a right angle to each other. We don't need this information. Sometimes in a problem in math, you might be given extra information you don't need. So we have 6.2 times 11, and like I said, we'll just do that on the calculator. 0.5 times 6.2 times 11, and we get 34.1 inches squared. And we've got another one here. We've got a perimeter and area of the following figure, also called an equilateral. Well, an equilateral means every one of these sides is 0.48. And we talked about angles before. Remember, these all add up to 180, so each angle in an equilateral is 60. Not that we care for this particular problem. Now, for perimeter, let's look at our formula sheet. Well, I see a formula for area of an equilateral. Hey, but I don't see a perimeter. Well, we don't need a formula for perimeter of polygons or straight-sided figures. Your perimeter is simply the total of all sides added together. So we're just adding the three equal sides together, or if you like shortcuts, you can multiply by 3. In fact, I'll do that in the calculator. And that's going to be 1.44 miles. Now, I do need a formula for area because I don't know my height here. And on my formula sheet, I do have a special formula for area. We'll need a calculator for this. So I have 0.433 squared. Well, what is A? On your sheet, write this down. That is the length of every side. Every little side is A. They're all the same, so we just need the length of one side. So A is the length of the side, just like it is in this hexagon. Now, order of operations, we want to do this first. Your calculator actually knows the order of operations, but let's just be careful. Let's put it in ourselves in the correct order. 0.48, hit our square, times 0.433. And I don't have any rounding instructions, so let me round it to 3 decimal places. If I do that, that's going to go up, that goes up, and that goes up. I actually end up with that if I round it to 3 places. Okay, now this next figure, we have a hexagon, and we'll have some more hexagons on the next page, and so we'll stop right there and continue in the next video.